Hello, and welcome to episode 181 of Quarkus Insights. So today we've got a special guest, Eddie Carpenter, and we're going to be talking about JDiameter on Quarkus. And sometimes rank our guests in terms of specialness. And so when we have colleagues, they're not very special guests. And by that metric, I think you are an expert special guest. Can you want to tell us what time it is for you, Eddie?
Sorry, just repeat the question.
Can you tell us what time it is for you?
It is just after 2:00 in the morning.
So yes, this is heroic special guest. So thank you very much, Eddie. We really appreciate you coming in at this extremely antisocial hour to tell us about the work that you've been doing with JDiameter and Quarkus. But before we jump into that, I will just cover some little news, mostly because it gives me the opportunity to push the news button, which is very exciting. And I think we haven't got too much news, except we have released 3.15.1, I think, which is our next LTS version of Quarkus. So actually that is quite impressive news and quite important news, because the LTS train doesn't come along too often, and it's just left the station. Is there anything else that I've missed, Eric?
We've got DevOps next week.
DevOps next week, yes.
DevOps Belgium.
Yeah, so I think we haven't got a Quarkus Insights next week because most of us are either going to be already at DevOps or in transit to DevOps. So we'll be back the week after that, but hopefully we'll have lots of interesting discussion about DevOps when we get back.
Yeah, we could almost do like a recap episode.
Yeah, actually, yeah, we should have done that. We could do summaries of all the best content. There's a ton of Quarkus content at DevOps this year as well, which is really nice.
Yeah, a huge portion of the engineering team is going to be there too. So it'll be fun.
Oh, and Eric's left for DevOps already.
That was weird.
Yeah.
I didn't do anything. My hands are like on my lap here. I didn't touch anything.
Yeah, no, you just poofed out of existence. But the good news is we don't actually need you because it's Eddie who is our special guest. You're just a non-special host.
Somewhat pretty face.
Yeah. And so with that, let's switch to Eddie, and perhaps you can tell us a little bit about. Oh, we've lost Eric again. Oh, technology's the worst. I'm glad it's Eric who's flipping in and out and not you, or we'd have some challenges.
Well, I hope so as well.
Yeah. So maybe give us a bit of background about who you are and that kind of thing.
Well, yes, I think as everyone heard, my name is Eddie Carpenter. I'm a Java software engineer, architect, I'm an IT executive. I emigrated to New Zealand about 3 years ago with my family. And for the last year or so, I've been freelancing as a Java architect. And I'm actually considering going back to being full-time employed. It's very glamorous to work as a freelance consultant, but I do miss the consistency of a fixed workplace and not having to switch between different customers every other day.
Yeah. And the dream is being your own boss, but then you discover that your boss isn't actually very good sometimes.
No, you're the only worst boss you can think of.
Yeah.
Worst guy I've ever worked for.
Yeah. No career support, no empathy.
No leave.
Yep.
No raise, no vacation.
Yeah.
Exactly.
Yeah. Well, we'll be interested to hear how it goes and what you decide, and hopefully we'll get you back another time and we can get an update. So can you tell us a little bit about JDiameter? Because I think probably for most of us, it's not something that we're super familiar with. So we were sort of interested to hear how it was being used with Quarkus.
Well, JDiameter is I don't know. Do you actually want to switch to the presentation? Or
Yeah.
You can do it from there.
Yeah.
Well, so diameter as a protocol is part of the class of authentication, authorization, and accounting protocols, so those famous AAAs. It evolved out of the radios protocol, which I think a lot of people are familiar with. Bit of useless information there. When the developers of radios realized that the protocol is sort of limited in what they want to do, they set out to develop a new version, version 2 of it, and was initially planning on calling it radius 2, and someone then said, well, radius times 2 is equal to diameter, hence diameter.
Perfect.
It's a bidirectional asynchronous protocol. It's defined in RC 6733. And it consists of a set of commands with attributes, where the attributes are normally defined as a message and a attribute value pair. What makes this protocol quite interesting is the fact that it's extendable at an application level. So it's sort of known as diameter applications, and it allows you to define new commands, attributes that goes with that command, and then processing rules. So the base protocol provides you with the handshaking, the connecting to a peer, watchdog functionality, capability exchange requests, where the one client actually determines what can the other client do, and whether that client can actually do what I want him to do. But then from an application perspective, or a diameter application perspective, you then have to implement the actual processing rules, and obviously both ends have to implement the same application and to understand it and actually to use it. And all these diameter commands or applications are actually registered with IANA, so it's a regulated protocol. One of the well-known extensions is RFC 4006, which is the credit control application, and then 3GPP has done a lot of extensions, and that is really where it's got its footprint into the telco space. So yes, today diameter is probably one of the core protocols in use in most telcos.
Is it used in other industries as well, or is it sort of?
It is, but it's mostly seen in the telecommunications space. I do know that your fiber providers also use that, but they tend to use radius more than diameter.
Yeah.
You know what's interesting though is that you've been talking. We always talk about how terrible developers name things. In this case, I think it was actually a pretty good name.
Yeah,
it is, and at least it's not a 3-letter acronym. Well, unlike 3GPP, which incidentally actually stands for Third Generation Partnership Project. So one of the challenges that your operators were facing towards the latter end of the 1990s was that they were sort of locked in by the vendor providing them equipment. So they would get from a product from vendor A, and then they had to stick with that product for the whole network. And they couldn't, for instance, use vendor B's product. And they then got together and said, well, they need to provide a standard to create interoperability between these various vendors. And really, that was where this whole concept was born. So they elected the diameter protocol to actually define communication between all the network elements in a 3GPP compliant network. So maybe to give a better understanding of it. So for instance, a mobile operator, a subscriber, wants to make a call. The lower network elements would then connect to the charts application and do the checks there to say, well, does this subscriber have the funds? Can he make this call? Is he allowed to? Another example would be I'm onboarding a new subscriber. I now need to propagate this information throughout my network. And that would be done using a diameter message, or I might be defining a new policy as to usage on the internet. And that would again be defined using a diameter message, which you then send off to the relevant network element to actually then accept it. So the whole network is defined with various diameter applications. And really what 3GPP has done is, in the telco space anyway, really promote diameter as a protocol to, even if you want to then from a application developer perspective, want to interact with a component in your network stack to either enhance it or extend it, you would then be using the diameter protocol.
And I'll just add that Eric is very kindly demonstrating what happens if you don't get your networking right by having his internet connection sort of slowly crumble over the course of the podcast.
And like every good developer, I'm going to point the finger at somebody else.
Well, that's the last time you try and blame someone else.
Yeah, that's what I get for blaming somebody else.
Sorry, carry on, Eddie.
I'm glad you could have some fun at my expense.
All right, so looking at JDiameter, I suppose the name already hinted towards it. It's a Java implementation of the diameter protocol. It was developed by these two gents 16 years ago already. So it gives you an idea also as to how long this protocol has been around. It's one of the few open source implementations for Java. There are others, not as comprehensive as the diameter. There are a couple of commercial diameter stacks, but most implementations tend to go the route of developing it in something like C++. As in a telco environment, speed is, in most cases, very important. And the quicker you can process something, the more or higher the volume that you can cope with. And you can also understand that if I'm browsing the internet or watching a movie on Netflix using my phone, I can't have a 3-second delay while the network elements try to find out whether I can actually get more data to browse further. You have to have these things in tens and 20s of milliseconds processed and answered. So it's I think one of the big things, and also why, and I'll get to that later, why adding the native capability to JDiameter was so important. Coming back to what are the challenges with diameter, because those all things normally are born out of a need or a problem. And in this case, JDiameter, all support has stopped about 7 years ago. I'm not 100% sure as to the history as to why it's other. It was written in Java 1.7 source code, so there are a lot of old patterns and ways of doing things which are not the case anymore. But all the dependencies that they used were outdated or not supported anymore. The number of dependencies that actually had CVEs against them, a lot of them were due to the log4j bug, but there was a couple of others as well. It was quite heavily dependent on something called pickup containers. I don't know if you guys know about this. It's a dependency injection model developed for standalone applications. But again, same problem. It was support for pickup containers was stopped in 2014, and that's 10 years ago. And then it used its own concurrency model, but it was using thread groups as opposed to thread pools, and we'll see later why that is relevant. So it actually was one of the things where I got quite frustrated in it became this choice between, should I find myself a different vendor of a diameter stack, or is there something I could be doing about it? And maybe just what I've been using it for, but finishing that last sentence. So I got quite frustrated in the limitations and the lack of support that there was in the product. So I was using it, coming back to that, for developing online charging systems and dynamic routing agents, which is two types of use cases using Diameter. I actually have a demo on the online chart system, so we'll cover that a bit more when we get there. But the solutions that I was developed using microservices, using Quarkus, and here's one of the big frustrations, and that is JDiameter was sort of a sidecar in the same JVM. It did its own thing, started its own stack, and there was not this cohesion between the environment, wasn't really embedding itself into the Quarkus ecosystem. And then as Java and Quarkus improve in speed and functionality, it really became evident that the stack really needs some TLC. And yes, that brings us to why did I do it? I had a gap between projects. I was frustrated with Diameter, and I decided to do something about it. I think like most open source projects, that's normally how things happen.
Yeah, it's the sort of the beauty of open source, isn't it? If you don't like it, you can fix it.
Exactly. And I think that was exactly where I got to. I said, well, I can't be complaining about this open source software that has served me well for quite a number of years. And maybe it's time to actually give back a bit. So yes, I then set out to actually develop this extension in Quarkus, and I sort of gave myself 5 main objectives of what it is that I wanted to achieve in doing this. Well, the first is quite evident, and that was we had to modernize the JDiameter core. We couldn't leave it as it was. So all updates, dependencies was updated, and some of them quite challenging because they were 2 or 3 major versions behind on whatever the dependency is. So you sometimes had to rework a piece of code simply because the method they were calling was deprecated and removed. We had definitely had to move from JavaX to Jakarta, and then also fix the code so that it's compilable in a Java 21 compiler. And it was also one of my objectives. I really wanted to be able to generate Java 21 source level code so that we can actually get to use the newer functionality in the language. The use of Picket containers had to be designed out. And then talking about the thread group I referred to earlier, that was replaced using thread pools. And that really gave us access to using executing services. So also getting to one of my big objectives, I wanted to be able to use virtual threads with Diameter. JDiameter is quite a thread intensive application or stack. Use concurrency quite a lot, and by being able to actually use virtual threads, you can really speed it up. And
speed up the development as well, I imagine.
Well, not so much the development, but you can get more out of a specific stack. So it's this challenge of, so especially when you now deploy this as a microservice, how many concurrent connections can I handle in one microservice before I actually have to scale it up? And how many services do I need to have to serve a base of 1 million subscribers? They're all busy making phone calls, browsing the internet, sending text messages, and they all want to do it instantaneously. So the more you can get out of one service, the cheaper it is to operate the solution. So that's, I suppose, one of the objectives. Coming back to the executive service, and this is also part of the objective, was to try and use the concurrency processing that was provided by Quarkus, to actually use the Quarkus provided executive service instead of doing our own thing. Then a couple of minor enhancements where you sort of saw that there's a need to actually improve something, but here was the big challenge. One had to strike a balance between the old way and new way of doing things. They employed old patterns which were relevant patterns for the time and the constraints of the language. But if you were to do it again in 2024, then probably wouldn't have done it that way. And this is now where you have to bite on your lip and say, well, I'm not going to change it now. I know that that's not the way that one should do it, but rather accept it as it is. Moving on. So the next thing was to simplify the way you configure it. The legacy JDiameter was using an XML configuration file, which, if you remember, I was talking about having it as a sidecar. So you had Quarkus running out of an application properties file, but then your diameter stack was configured using an XML file. And I set out to say, well, I would really like to have my diameter configuration also in my application properties file so that it's controlled in the Quarkus ecosystem. And now we're getting to the niceties, and that is, I want to be able to inject the diameter stack and the configuration that I've defined into a container control object so that I can actually get access to this stack. Define synthesized beans so that I can allow me to inject it by just referencing the actual config name. Make it easier to actually use it. And the fourth objective I had was to simplify the way you would code a diameter service in a client. There was a lot of boilerplating that one had to do to get the service to start. I actually wanted to have some kind of interceptor framework that does all those boilerplating for you and then hook it into the Quarkus ecosystem. One of the big things there is to actually attach the stack to your shutdown handler so that when your Quarkus application terminates, it actually terminates your stack as well, which is one of the big challenges we had. Your stack would sort of live on until Quarkus really pulled the mat out underneath it. At least now you can actually do a graceful shutdown and it now, well, that was the objective in a way. It should feel like it's part of the application, it's two applications running on one JVM. And then the last one was to add support for native applications. Being able to compile a JDiameter application to a native was really something I was after, because I was after that speed that you get from running it in native. And if you remember, I was saying that a lot of vendors or a lot of people were using C++ to actually develop these components. It was really because Java, I think, initially was too slow. And really what now are happening is that it's putting it slowly back into the realm where it becomes feasible as a solution. And then there has to be a bit of fun in doing something. So it was for me to learn more about coding to Quarkus extensions, which actually something I've enjoyed quite a bit. All right, so that brings us sort of to a demo.
Cool.
Gonna just show a very simple diameter service, online chart system that always decline the subscriber, but really the idea there is to show the audience how easy it is to now define a diameter service and get it up and running with a minimal of coding. Then the next one is to actually do a bit of a staying on the chart services, actually have a bit of a simulator for simulating a process where I can make a phone call. I'll talk a bit more about how that works when we do that. And then I have the two versions, a Java version and a native version, and we can then see how it actually does increase the latency and speed. And then if we have time, we can maybe look at the JDiameter extension that I did and maybe have a bit of a review there. All right, so if we just start with just a very simple application, I cheated a bit by creating the application in advance. But I mean, really all you need to do is have your Quarkus. You can see already on 3.15.1 and also the latest JDiameter version is already compatible to 3.15.1. And it's as simple as adding that as a dependency, like all other extensions. Then looking at the configuration file, this is basically all you need to do now. It obviously has a lot more if you want to get into the finer configuration and configuring it really to perform optimally, but defining the actual application, saying what is my PN name, or what is my realm, a bit of a name for. I see there's a mistake. And then here's where I actually register my applications that I support. Emma was talking about in that handshaking process, there's this capability exchange process where the two peers, when they connect, figure out what can the other peer do, so that we actually know that the peer that I'm connecting to can actually do what I wanted to do. And then here is a very important one, and that is to say, I would like to use virtual threads. Let's look at a very simple service. So here is an example of a diameter service. It is simple as you annotate any clause as a diameter service, and then you have to implement the actual the actual diameter listener that you're implementing, and those are all defined. It's in the documentation. You actually have quite a number of them that comes with the JDiameter stack. There are a lot more that hasn't been done, but again, the framework does allow for it to be added as and when someone actually realizes that they need it. But so this basically says I want to have a server that's a credit control application, and it's a session listener, and that's all I need to do. The diameter service will pick up that I want to start that type of application, and that I'm going to be not a client, I'm a server, and do all the boilerplate thing to connect that service and introduce it into a stack. Something I maybe neglected to cover when I did the service, the configuration. You could actually have more than one set of applications. So this is basically the default, and by adding a name here, you can actually have test and then have another set of application configurations. You could actually have 2 or 3 configurations in one config file, where it was one of the big challenges in the previous or the legacy JDiameter, that you could only have one configuration per JVM, and you were sort of stuck. And well, it's a half a truth. You actually had to do quite a bit of coding to actually support more than one stack, and now it's as easy as just defining the various stacks that you want. So switching back here, and then here's one is the method you have to implement. Very simply, just grabbing the start time, so we can print how long it took us to actually run this bit of code. It prints that application value pairs for you, so that you can actually see the message, makes it a bit more visual. I'm creating an answer, and I'm immediately actually saying we are going to decline this request because the subscriber has reached its limit. So there's no more credit. There's this adhering to the business rules around processing a credit control application. You have to set those values, and then I'm actually returning the answer back to the client, and I'm printing the response that I sent to the client, and then I log how long it took me to do this. So if we now go and actually have a look at this, again, I cheated. And now my cheat is not working. Typical. The demo gods involved. So just compiling it. Now, so that started. You can see the diameter extension is added. So I have a little test application that I developed over the years that I used to test any online chart system. I should have maybe said that both the demo and this test application is actually available on my GitHub profile. So if anyone wants to have a look at it, it's more than welcome to clone the repository and have a look at it. But anyway, so what this application really does, it simulates a phone call. It's going to connect to the server, ask for 5 seconds of talk time. If granted, it will then consume that 5 seconds, then and go back and say, well, I've used the 5 seconds you gave me, gonna have 5 more, and it'll do that a couple of times, and then eventually terminate the call or simulate the termination of that call, reporting the last usage. In this case, the server is going to say, no, you don't have the funds, and it's going to terminate immediately. So I run that application.
That's probably what happened to Eric.
Have we lost Eric?
Yeah.
So and here on the server side, you can see here's the request that comes in. That is basically that attributes that goes with the application. So the credit control application have these, and these by no means are all the AVPs that's defined, but these are just the ones that were either mandatory for the specific application or optionally and provided. Can ignore most of this, and there you can see it's a request for 5 seconds of time, and the response that went back was to say no, I can't. So there's result code 4012 that has a predefined meaning in the query control application, and that is the end. And it took us all of 9 milliseconds, but let's be fair. The JVM was just started, and it hasn't really loaded any of the classes, so it should actually now have a 3 to 4 millisecond response. 2 milliseconds.
Nice.
But the application not doing much. I mean, if you now remember, it literally prints that message to say this is what I got, and immediately then creates an answer that says no, I can't help you. I don't know. I don't care what you ask. It's no, and I send that answer back. So let's have a look at an application that actually do a bit more than that. So here's an application that has the same elements as the little simple server I had earlier, except that instead of not always answering no, it's now answering some kind of result code that is passed in there. And what it's going to simulate is exactly that process where I have 100 units. I created 100 units of usage, and when you ask for 5 units of talk time, it's going to reserve that. It's going to allow you to use it. You then report back to say, I've used so many of that seconds. At that point, it will actually then account for it and grant you the next 5 seconds. And that process will repeat itself to the point where you then terminate it. So a credit control application has an initial request, which is basically, hello, here I am. I would like to make a phone call. The update request is, you've given me, as part of the initial response, some time to use. I've used it, can I have more? And then eventually there's a termination that says, thank you very much, I'm done. So if you now compile that one.
Does this work in dev mode as well?
It does. It was just easier to actually demonstrate it on the screen here, especially when you're going to look at the AVPs that get printed out.
Yeah.
There's not a specific dev UI implementation for it, but yes, it definitely works in dev mode. That's the way I normally use it. So that started again, and this time there's going to be a bit more of an interaction. So looking at it, so there's your initial request that says the request to 5 seconds. The server then responds with, I will grant you 5 seconds. The client comes back and says, I've used 5 seconds. Can I have 5 more, please? Now, in a real life scenario, that's obviously different values and more variance in it. But anyway, going on, so that then continues itself until it gets to a point where it says, I want to terminate. Here's the 5 seconds that that was sort of used during the last part of the session, and I want to terminate. And the server says, well, thank you very much, I got that. And that's really sort of the normal flow for a charge system, and you do this for every subscriber, for every service that they consume on your network. So if the person makes a call, browse the internet, and send a message, then you'll have 3 sessions. And in actual fact, when they browse the internet using their phone, the various destinations gets classified into rate groups, so that, for instance, social media, your DNS service would be a different rate group. Normal internet would be its own rate group, and then you might have zero-rated destinations, maybe the telco operators, mobile application, etc. And each one of these rate groups actually ends up being a session on its own. For every one of these, your client actually has to establish a connection. So per subscriber being active, you might have 4 or 5 active sessions at any given time. So it's quite a lot of chattiness that you need to manage.
Yeah, that's really going to push the scalability, isn't it?
Yes. So no, we saw that we sort of running there in the 8 milliseconds space. That's sort of the average time that it was processing it. Obviously, if you now start adding a database behind it and really start doing some processing, so in a typical telco environment, a person would have bought a bundle or of some sort, which would grant them in a prepaid context, say a meg of usage, and you then actually have to consider this, but you might actually have a couple of these. So what I'm trying to get to is, you actually have quite a bit of processing that you have to do in order to account for this and to authorize this usage. So in a typical scenario where we're running it out of a Java environment, it's sort of on average 50 milliseconds that it takes or 40 milliseconds that it takes to actually do this processing. So you can actually see how even in this case, it's not really working that hard. If I can have 8 milliseconds in a production environment, I will be smiling from ear to ear. Anyway, I really wanted to actually now show what the difference running this in native mode makes. Compiling it to native quickly. Well, quickly, I think is maybe a bit of a misnomer here. It's not that quick to compile to native.
Yeah, usually when we do a demo, we do it beforehand.
The challenge is here that it's the same application.
Yeah.
I was actually planning on doing it 2 different versions of it and cheat a bit, but fortunately it doesn't take that long. It's about a minute to actually compile it to a native application.
It's not too bad.
No, but yeah, it's if you want to sit and watch this how it does this, it always takes longer.
Yeah, it's the nature of the native compilation, isn't it? Because it's doing so much work under the covers just to poke every corner of the application.
Yeah, but I must say it has gotten faster. I remember when I started out. I mean, it's done now.
Oh wow, yeah, it's done already.
Yeah. It actually took quite a bit of time and used significantly more memory than it does now.
Oh, that's really good.
Yeah. So then maybe the fact that I have a nice laptop also helps. Right. So running the native application. For now, repeat that same process where we run this little demo of simulating a phone call. We can see we're now running in the 1 to 2 millisecond range. It's a 400% improvement, 500, well, depending on what you take as your base. But it's a huge improvement. from that aspect.
Yeah, that's really impressive.
Yeah, I mean, so I can live with 1 to 2 milliseconds. I really could. And this is really what was one of my prime objectives, was to get this diameter to actually be part of the Quarkus ecosystem, and really to get to a point where you can actually compile it to a native application and get speed like it, and latencies like as one get now. All right, so are we looking for time? I think we sort of.
We've got about 15 minutes left.
We can either open it up for questions if there are, or can maybe just do a quick review on the extension itself. I'm just a bit concerned. I don't think the reviewing the code in the extension is going to be done within 15 minutes.
Yeah, so I think we haven't got too many questions, but I mean, I think what would be probably interesting is the sort of your experiences of writing the extension, and what did you find easy and what did you find hard, and that kind of thing.
It was definitely a bit of a learning curve. The thing I struggled the most with is actually the configuration, having a runtime and a build time configuration, and how to get those two to work together, and how can I have part of my configuration available at build time, but allow you to change it at runtime, because reality is all those settings that I showed you, I want to change at runtime. And I want to be able to add more to it, because reality is, as my network expands or as I start talking to other networks elements, I need to define those. Then the one thing that I struggle with is the documentation is not always as clear as it should be, or I didn't always understand what was they were trying to sort of that. I found that by actually going into the Quarkus GitHub repository and to Quarkus itself actually helped me more than trying to read the documentation. The documentation many a time was also outdated. But it was actually fun, and I think now that I understand how the mechanism works, it's quite easy. I can actually now go and look at an extension and say, oh, this is what they're doing here. Where when I looked at it the first time, it was overwhelming, and it looked like gibberish. You know, what is they doing here?
Yeah, I think especially that mental model of the build time and the runtime is such a different mental model, and so it's sort of you have to get your head sort of to grips with that before you even do anything else. Yes. And then I think as well, it's sort of, there's definitely interesting trade-offs that you maybe have to think about, like what you were saying about, I want to be able to change everything at runtime, because there is a trade-off between that dynamism and the speed. And so then it's like those tough choices of like, oh, well, I'd like to make changes at runtime, but if I could get away with doing it at build time, I would get this in return.
But that's what you actually saw, is that the native versus the Java version of the application startup time. And that's because the configuration is actually processed at runtime and not at build time. The only bit that's processed at build time is the various configuration names, because one needs that to actually create your synthesized bean, so you can actually inject it. But because that you have those injection points you have to define at build time. And the other thing that I had to get my head around was the fact that a recorder actually records bytecode which gets replayed when it starts up, and I sort of mistakenly thought it actually gets executed, interpreted, and executed at startup. But the reality is it actually gets compiled to bytecode during build time, and all it now does, it just runs it, which is also something you have to get your head around. And then within the recorder, to understand that all the various services are not available yet. You can't do what you would normally do in a fully runtime version. It's still sort of in between this. I'm not build time, but I'm also not runtime.
Yeah, you're right. Actually, yeah, I never thought of it in those terms, but you're right.
I'm sort of I'm not there, but I'm also not here. Then maybe just to go back to my presentation, is just wrapping up. There's quite a bit that one can still do to modernize the diameter core. It's by no means done. I think I got it to work. It works pretty well. Can definitely benefit with a tighter integration into the Quarkus framework, the ecosystem. One can. I'm definitely thinking of trying to get the socket management to actually be more in line with how Quarkus and Vertex does it. Diameter does support secure connections, although it's not as rarely used. But in the case where someone do want to use a secure connection, try and tie that into the TLS configuration within the Quarkus framework. And then the other one, which is I think probably the more important one, is the JDiameter stack currently collects a whole lot of statistics, but it's not externalizing that. And one of the things that I really want to do is to actually get those metrics collected and exposed through the normal metrics micrometer type framework, so that you can actually get hold of it and actually monitor your running environment.
Yeah, that would be really nice. Yeah, that's sort of a model that a lot of the extensions do, is that you, as soon as you add one of those observability extensions, you start to get quite domain-specific metrics coming in just based on what other extensions you have. Yeah, that would be nice.
So that's I suppose one of the things that I definitely, and then I would love more people would get involved. So far it's been a lonely journey just by myself, and it would be nice to actually discuss what it is and how you want to do it, and solutions that you're thinking of. Sometimes just talking to someone, and there I must say, Philip Kruger actually helped me quite a bit. Your colleague in Australia, just being able to actually talk to him about what it is I'm busy doing, and giving me some pointers. Go and look at this, or go and look at that. But that's, I think, sort of the Quarkus JDiameter extension.
Yeah, excellent. Yeah, I think so. Hopefully, because you've written a few blogs as well, haven't you?
Yes, I have. The one that when I launched the stack, definitely will be doing some more. I quite enjoyed doing that one. So it's.
So just I'll share that link in the chat as well. So if people want to read more, they can
I'll look at
they
that.
can go to that blog, and yeah, that call for community is definitely noted. That so if people want to get involved, is your GitHub repo the right place to start?
I think so. Just well, either send me an email or just start contributing. Log an issue or a suggestion as to something that can be improved, and one can then always pick it up from there and start talking about it.
Yeah, excellent. And so Yeah, I've shared that link as well for the
Oh, nice.
GitHub repo. So yeah, thank you very much, Eddie. This has been super interesting insight into a whole bunch of the world of telco that you don't really think about when you just make the call and assume that somewhere the magic happens. And
But there's quite a bit of magic that happens behind the scenes too. And I've discovered the higher layers of a telco environment, the tower management and all of that is actually also quite complex, and I wouldn't even start to try and pretend that I actually know what happened there.
yeah, and I think as you say, it's such a good fit too for some of the things that Quarkus offers in terms of that really low latency and that scalability and that kind of thing. So I'll be interested to see what happens. And yeah, Eric confirms that his whole ISP collapsed. So clearly not using any of this stack. So with that, I think we probably better let you either get back to bed or get on with your day, depending which way you decided to do
Well,
that.
it's now
that horrible
3
split.
o'clock, so I think I'll go back to bed.
Yeah, very sensible. And yeah, thanks again for coming and sharing it with us all.
My pleasure.